Okay, for this section we're going to get some practice balancing equations, and so we're going to work some problems from the back of your textbook. So this one is number 5.33 in the back of your book. So this is a multi-part question that asks you to balance 5 different reactions. So the first one is NO2 gas plus O2 gas to yield N2O5. So let's get some practice naming these before we start. So if we've got, is this ionic or covalent? So you should have said covalent because there's 2 nonmetals. And we know there's only 1 nitrogen, so we're going to call this one nitrogen dioxide. This one is oxygen, molecular oxygen. And what is the product called? The product is dinitrogen pentoxide. So that just gives us some practice naming. And now we need to see about balancing our equations. So we know we've got 1 nitrogen over here, and we've got 4 oxygens on this side. And on this side we've got 2 nitrogens so far, and we've got 5 oxygens. So these are not balancing with each other. Well, the first thing that I notice is that I've got odds and evens. Odds and evens are bad when you're balancing chemical reactions because they're not going to balance each other unless you make them both evens. Right? So the simplest way to make this an even is to double it so that you end up having 10 oxygens there. So I know even before I start, I'm going to have to get the oxygens to an even state. So I'm going to try placing a 2 as a coefficient on this side. And what does that do to both of these guys? It expands to both the nitrogen and the oxygen. So now, instead of having 2 and 5 oxygens on this side, I've got 4 nitrogens and I've got 10 oxygens. So that's a lot. So that's a lot more than I have on this side. But now I can start working with these. And so this one here is more complex than this oxygen here. So we're going to leave this one to balance last. So now I need to get 4 nitrogens. So that's I'm going to be able to accomplish with this compound by adding a 4 in front of this one. So if I have 4 NO2s plus, we don't know how many O2s yet. We're still working that out. And I'm going to have 2 N2O5 units here, and that's still in the gaseous state. So these are still all gases. Okay, so now what do I have on this side? I've got 4 nitrogens, and I've got 4 times 2 oxygens, so I've got 8 oxygens now. And I've also got the 2 oxygens over here. So I've got a total of the 10 oxygens. I think I'm balanced. Plus the 10 oxygens over here. So I don't need a number in front of this. It's going to be 1. So my overall balanced equation for this reaction is going to be 4 NO2 gas plus O2 gas yields 2 N2O5 gas molecules. So that is my balanced equation. I have the same number of atoms on both sides. Alright, let's do another problem. Okay, so this is my second equation. So I've got P4O10 solid form plus water in its liquid form yielding H3PO4 on this side in the aqueous form. So initially, let's name these guys again. So if I've got P4O10, I've got tetraphosphorus, deca oxide. So 10 is deca. And then we know water, and then this one should look familiar. It's phosphoric acid. Is a polyatomic anion that you're familiar with. Okay, so let's look at balancing now. First, summarize what you have of each atom in here. I know I've got P, H, and O on this side, right? So I've got 4 P's. I've got 10, 11 oxygens. Odds doesn't make me happy. And I've got 2 hydrogens. On this side, I've also got these 3 elements. Put them in the same order. So for phosphates right now, I only have 1. Hydrogens, I've got 3. I don't like odds. And oxygen, I have 4. So we have quite a bit more oxygen on this side of the equation than we do on this side of the equation. And we also have quite a bit more phosphorus on this side of the equation than we do on this side of the equation. So phosphorus is the most complex element that we have in here. The rest are hydrogens and oxygens. So I want to balance the phosphorus first. So I think the easiest way to do that is to try placing a 4 in front of this molecule so that we can get 4 phosphates in here. And let's see what that does to our numbers if we place 4 in there. So these guys are going to all be different now. So 4 times 3 is going to be 12 H's. 4 times 1 phosphate is going to be 4. And our oxygen is going to be 4 times 4 is 16. So now we have more hydrogen and oxygen on this side. And our hydrogen is going to be even now. So I like evens. Evens are divisible. You can usually get evens on the other side. So now we've got phosphates matching. So now we need to see if we can get oxygen kind of on board. So we're not going to change this unit because our phosphate's matching now. So the 10 oxygen that are here have to remain the same. Plus we have a number of oxygens that can come from our water molecule. We need 16 over here, right? So we need 6 more to come on this side of the molecule. And those have to come from our water molecule. Since there's only 1 of these on each, I'm going to say that we've got to have 6 water molecules on this side. If we have 6 water molecules on this side, that'll give me 6 more oxygens. My oxygens would then match. And then let's check our hydrogens. Since we've got 2 of these for each one here, that will give us 12 hydrogens. So now we're going to match. So our final equation is P4O10 in the solid phase plus 6 water molecules in the liquid phase. These come together and react to form 4 molecules of phosphoric acid in the aqueous form. Okay, so that is our second balanced equation. So again, it really helps to write out what you have and then start with the most complex atom that's in there. So if you've got hydrogens and oxygens involved, balance those guys last. So start with the more complex element that in this case was phosphorus. Okay, let's do one more example. Okay, so this one is taking B2H6 plus O2 and making B2O3 plus H2O. So let's try to name these. So when we're analyzing this equation then, let's start just by listing again the elements that we have. We've got boron on both sides, we've got hydrogen, and we also have oxygen. So each of these so far we've got 2 of these on this side. We've got 6 hydrogens and we've got 2 oxygens. How about this side over here? We have the same atoms on this side. We've got 2 borons, so these guys are matching so far. But we've got 3 oxygen right here. However, there's 1 more over here, so we've got 4 oxygen total. And we've got 2 hydrogen. Okay, so if we're looking at our equation, we can see that we've got less hydrogen over here. We've got more hydrogen over here. We've got less oxygen over here. And we've got more oxygen over here. This is the simplest compound right here, so we're going to balance that guy last. So the first thing that we need to look at, our borons are balanced, so let's leave those alone for now and see if we can do this equation without having to change our number of borons. So we're going to say these look good. We're going to leave these two guys alone. So we're going to say B2H6, and we're going to leave that alone. Plus our oxygens, and we're going to come over here. We're going to leave this term alone too, O3, in the solid state. Now, I don't know if this will work, but we're going to try it out. So the next thing that we need to balance then is going to be our hydrogens, right? Because this is the more complex compound than that. So let's try to balance this next. So if we want to balance our hydrogens, we've got 2 on this side, 6 on this side. So I would say if we have 3 water molecules, that'll get us up to 6 hydrogens. So let's try that. If we have 3 water molecules on this side, what does that give us? We've got B, H, and O again. We've got 2 borons. We're going to have, this is going to go to both units out here. So we're going to have 3 oxygens plus 3 more oxygens for a total of 6 oxygens. That's even. I like that. And our hydrogens are going to be 6. So now we've got on this side, we've got 2 borons, we've got 6 hydrogens, and so far we have 2 oxygens. We have 6 here. So if we have 3 of these guys, I think with that will get us to a balanced state for a total of 6. So do these all check? 2, 6, and 6. So this is our balanced equation. Alright, are you starting to get a hang of balancing equations? Again, I write out what I have as far as the number of atoms on both sides, and then I start with the most complex thing. In this case, it was the boron, and I try to balance it first. It was already balanced, so we left it the same. And then I noticed that our oxygen is the simplest thing, so I went to balance the next complex thing, which was, in this case was the hydrogen, because it was in compound with the oxygen. After balancing that, it was easy to finish balancing the oxygen on this side to match this side. Alright, so those are 3 examples for balancing chemical equations. You'll get a lot more practice doing this in class and in lab.